Today we are going to mainly talk about two reactions. One is called the iodoform reaction. Iodoform, the name is similar to chloroform. And if you remember correctly, chloroform was that you had carbon with chlorine substituted instead of hydrogen. And that was chloroform. Just like that, over here, iodoform is a similar thing. That instead of having CH4, you have three of those hydrogens substituted by iodine, and that's iodoform. All right. So we can also call that triiodomethane or iodoform. So iodoform reaction is a useful reaction to figure out the structure of an alcohol. Now, here's the thing. If you have a carbon that is attached to OH, but at the same time, that same carbon is attached to a CH3 as well, then you can have iodoform reaction. So the same carbon that's attached to OH, if it is also attached to methyl, then that can be oxidized by iodine to a carbonyl thing. So here's how the process works. Let's suppose I have this compound, and on one side I have hydrogen, on this side, let's say I have C2H5. What kind of alcohol is this? Primary, secondary, tertiary, what kind of alcohol is this?
Sir, secondary?
It's secondary, yeah. And what I'll do now is that I will add iodine in an alkaline solution. So I could add maybe iodine with sodium hydroxide solution, okay? And then I will heat it. Now what happens is that this carbon will be oxidized, okay? So when alcohols are oxidized, what do they become? Secondary alcohols. We've talked about it. You have to remove two hydrogens. So you can remove this hydrogen and that hydrogen. So when you do that, you now have this oxygen in a double bond, and this C2H5 stays there, this CH3 stays there. So you simply oxidized this carbon. Okay, but this reaction is not complete yet. The reaction keeps on going. So first step, it oxidizes. Second step, this oxidized thing, let me rewrite this. This thing changes by substitution. What happens here is that this carbon, the one that was attached to this carbon, the one with OH, ये जो methyl group है, it will be it will basically be substituted, and what you will get now is Ci3. So the methyl group will change to Ci3 because you have iodine, lots of it, okay? So that's going to substitute in there. And of course, alkaline solution helps. Now, the next thing is that in presence of Ci3, what happens is that this OH minus, so this Ci3, the OH minus is going to attack this, okay? So this thing is going to be attacked by OH minus. What's giving us the OH minus in this setup?
So the alkali.
Alkali, very good. So the alkali is giving us OH minus, and what that does is that hydrogen goes with the carbon and oxide goes in place of that. So now you're going to get, C2H5 as it is, this carbon as it is. But now in place of Ci3, we are going to get O minus. And that carbon is now going to be joined with the hydrogen. So basically hydroxide ion has given the H to carbon, and the oxide has replaced Ci3. And this thing is iodoform. And it has a yellow color, and it's insoluble in water because it has not that polar a bond. the carbon and iodine, they don't have very large difference of electronegativity. So that is why you're going to get a yellow precipitate.
Sir, but where did the H come from in this?
Yeah.
इसमें H OH से आया था.
Yeah. And then because you already have sodium ion present, that sodium ion can react with this propanoate ion and form sodium propanoate. Sodium ion kahan se aaya? Alkali se. So you're going to get this propanoate minus and Na plus. So you are going to get some solution of this acid, this ester, okay, and a yellow precipitate. So let's go back. What happens? You have basically oxidized a secondary alcohol. Of course, it doesn't have to be secondary alcohol. It has to be an alcohol in which you have methyl group on the same carbon as OH. That's important. दूसरी side पे कुछ भी हो सकता है. But on the OH side, you must have methyl group on the same carbon. So एक ही carbon है, उस पे OH है, उसी पे methyl है. बाकी जो मर्जी हो, कोई फर्क नहीं पड़ता. That thing is oxidized to a ketone. That ketone undergoes substitution. That substitution thing then undergoes another reaction and you get CHI3 iodoform. And the negative ion forms ester. Important thing to remember, the methyl group is going to go away, which means the carbon, if this was butyrol, you will end up with something that is prop, because one carbon has been taken away, the methyl has been taken away. So in general, overall reaction kya hoya? You started with methyl here and OH here and something attached on the other side. Yahan pe C2H5 tha. You added iodine, you added sodium hydroxide, and overall you ended up by taking this into CHI3 plus. This thing has now changed to this Na. So अगर गौर करें तो technically all that has happened is that this has reacted with this and given us iodoform, which is yellow. This sodium and oxide has come and reacted with this carbon, and this hydrogen has come and reacted with this. लेकिन इसको इस तरह से याद करने से बेहतर है कि आप understand करो that iodine is going to help us form iodoform, and the hydroxide is going to help us first oxidize the carbon, the alcohol, and then form an ester from that. So that's iodoform reaction. Let's take an example of this. What's the necessary requirement for having an iodoform reaction? You must have methyl on the same carbon as OH. Only then iodoform reactions happen. Okay, so I'm going to give an example. Okay, iodine in presence of sodium hydroxide, aqueous. What should happen? So we should get iodoform, which is triiodomethane, plus, so this is oxidized, this is taken out. So I'm going to get C with CH3, this thing with oxide and sodium ion. That's what we'll get. Will ethanol do this? The iodoform reaction.
Yes, sir.
Why?
On one carbon it has OH, and then on one it has CH3.
No, on the same carbon it has CH3. It's important that it's all on the same carbon that has OH should have a methyl.
So in the one above, won't both of them get replaced or only one?
Only one takes part in the reaction. क्योंकि देखो एक दफा उसने रिएक्ट कर लिया तो उसके बाद OH goes away. So there's no OH present to help facilitate it for the second one.
Oh, okay.
Okay, if I gave you this thing, will this do iodoform reaction?
No, sir.
No, it won't. Yes. Okay, let's try some skeletal formulas. Will this do iodoform?
Yes.
Yes, it will, because this carbon has methyl as well as OH. Okay. Will this one do iodoform?
Yes, sir.
क्यों?
Because they're 8 with OH and then on the same carbon it has CH3.
It has two CH3. Yes. Okay. This one.
No, sir.
This one.
Yes.
Done. Okay. So that is iodoform reaction. Iodoform दोबारा से देख लें. Iodoform reaction is when you have OH on the same carbon as a methyl, and that is when yellow precipitate of triiodomethane forms, and that basically tells me that you have a carbon with a methyl group as well as alcohol. So it's kind of telling me that you have a secondary carbon or ethanol, because I can't think of any other. There's only one primary carbon that can do this. Because if you think of propanol, it won't do it. Will methanol do this?
No, sir.
Yeah, it won't. So there's only ethanol that will do it. And then you have secondary carbons that will do it. Tertiary carbons won't do it because they can't give us the oxidation part. Oxidation is important. All right, so that's done. So now we have a very simple way of identifying alcohols. Okay, so if I have primary alcohol, then tell me, will it react with the sodium dichromate or potassium dichromate?
Yes, sir.
It will, yeah. And the color change would be, it goes from orange to green. Okay.
Yeah.
Now, here's an interesting thing. If I distill it, so I add an oxidizing agent and I distill it. I do the same thing with the secondary alcohol. I add a strong oxidizing agent, I distill it. With a tertiary, I do the same thing, add a strong oxidizing agent, distill it. Okay, so initially, let's suppose my oxidizing agent is potassium dichromate. So in all of them, the initial color is orange. What will be the color after the process, this process, distillation and oxidation?
So for the first one, will it still be orange?
If it is still orange, that means it hasn't reacted. Can't we oxidize primary alcohols?
We can.
We can. So the color will change and I'll get a green color. Can we oxidize secondary alcohols? We can. So the color will now be green as well. With tertiary, can we oxidize them? Tertiary alcohols don't have two hydrogens to provide. And because they don't have two hydrogens to provide, they can't be oxidized. So it will stay orange. So there you go. You take an oxidizing agent, add it to an, as long as you know that there is an alcohol. So you must first know that I have alcohol. And then you react it with an oxidizing agent, a strong oxidizing agent. If you distill the product and the color changes, then only tertiary is not unaffected. So if you know this thing is an alcohol, but it does not oxidize, that shows it's tertiary alcohol. Okay. Now I take this solution, the green one, I've distilled it. I add a weak oxidizing agent. Weak oxidizing agents are tolerance reagent or Fehling solution. So I do the weak oxidizing agent with both of them. The secondary one, the product of the secondary, and the product of the primary. So in the primary one, when you oxidize it, and you distill it, you basically convert it to aldehyde. So if you had ethanol, now it will be ethanol. Okay. And with secondary one, you can just oxidize it, convert it to ketone. Now remember, aldehydes can be further oxidized to carboxylic acid. But ketones can't be further oxidized. They don't have any hydrogen to provide. That is why when you further oxidize them, so let's suppose I'm using a Fehling solution. Fehling solution is blue initially. So it is blue in the beginning. So Fehling solution is blue. But that color changes to red in the first one. Why? Because aldehyde can be oxidized to carboxylic, but ketone cannot be, so it stays blue. So now we have a way of differentiating between primary alcohol, secondary alcohol, tertiary. What's the method? Oxidize it. Tertiary doesn't oxidize. Secondary oxidizes only once. Tertiary can oxidize twice. Primary can oxidize twice.
Yes, sir.
Okay. So that's a really easy method of understanding whether you have alcohols or alcohol group or not. Another way of identifying that you have alcohol group, that would be that I take an alcohol. So this is the second way of identifying whether you have OH or not. So while we know that this method confirms what kind of alcohol you have, so this is a method to know what kind of alcohol. Do you have primary, secondary, or tertiary? But do you have OH? How do you confirm that? So confirming OH. So how do you do that? You basically have two methods. One is you can take the alcohol and react it with PCl5. Why? Because PCl5 will form HCl. And that HCl will give us white fumes. Now here's the equation for that. Let's suppose I have ethanol. So what it will do is that PCl5 will react with it. One chlorine goes and replaces OH. So you have this thing, chloroethane. One chlorine goes and forms HCl. The other three stay there and form POCl3. And there you go. That HCl is going to give us white fumes. And because of those white fumes, we are able to see that, yes, we have OH. The reason it happens is because OH break down, but first the chlorine comes in and then OH breaks down. Another way of confirming whether you have OH or not is you react it with sodium. Why? Because alcohols can act as weak acids. Okay, so alcohol plus sodium or even potassium will give us bubbles of hydrogen gas. Why? Because these acids, especially the small ones like ethanol, methanol, they are weak acids. Okay, so what they can do is they can react with sodium as acid, give H positive away. So if I have ethanol, then it will react with this, form sodium ethoxide. And we have already talked about why ethanol is a stronger acid than methanol. And this gives hydrogen gas. You can check hydrogen gas by that pop sound wala test.
So why
I'm sorry?
is ethanol a stronger acid again?
So any acid, whether it's a strong acid or not, depends on how stable is its base, the conjugate base. Okay. Sorry, ethanol is a weaker acid than ethanol. And the conjugate base of ethanol, which is ethoxide, is not as stable as the conjugate base of methanol. The reason, if you look at methanol, it will get this thing, which will then oxidize to this thing. So what's happening here is that this methyl group is giving a positive inductive effect to oxygen, making it more negative. When it makes it more negative, the equilibrium drives backwards. So ये इतनी stable नहीं है. But with ethanol, the base formed is ethoxide, not methoxide. And this has a greater positive inductive effect of the ethyl group. So because of the inductive effect of ethyl group, this is more negative. When it is more negative, it pulls it more strongly. When it pulls it more strongly, it drives the equilibrium back zyada. That's why it's less stable. This is relatively more stable. But at the end of it, both of them are not that stable. So let's summarize what alcohols do. First of all, how can you get alcohols? सबसे पहला method alcohol बनाने का हमने देखा था, that you take alkene, and this alkene you hydrolyze it. Okay, how do you hydrolyze it? You use water, you use H3PO4, 60 atm pressure. Okay, or you can also use 350 degrees Celsius and 100 atm pressure. दोनों में ये reaction obviously ज़्यादा pressure होगा, ज़्यादा तेज होगा ये. And this converts it to alcohol. ठीक है. अगर आपने ये नहीं करना, what is this process? This process is electrophilic addition. अगर आप ये नहीं करना चाहते, then another way of doing this is if you have halogen alkane. If you have halogen alkane, you can convert it to alcohol by replacing the halogen with OH group. And to get the OH, you need alkali. So you can take alkali in water. Okay. And what happens is that you just need to heat it under reflux, because once alcohol is formed, it can evaporate away. And this process is not addition, this is substitution, because it's substituting the alcohol, the halogen with alcohol group. So bromine or iodine or जो भी है, it will be substituted. अगर ये आपने नहीं करना है, if you have a carbonyl group, कार्बोनाइल ग्रुप में क्या आता है आपके पास? कार्बोनाइल ग्रुप में आपके पास आ जाते हैं एल्डिहाइड्स, कीटोन्स, कार्बोक्सिलिक एसिड्स. So carbonyls can be converted to ethanol or alcohol by reduction. अब reduction के हमारे पास दो तरीके हैं. एक तरीका है you add hydrogen with nickel catalyst and high temperature. If you don't want to use nickel, you can use platinum as well, लेकिन वो थोड़ा महंगा पड़ता है. Or you can use a reducing agent. Reducing agent hydrogen इस तरह साइन होता है reducing agent का. ठीक है. There are two strong reducing agents in our syllabus, लेकिन वो अभी हम नहीं करते हैं. ठीक है. So you can make alcohols from these things. Now, what can you do with alcohols? Obviously you can burn them. So अब हम देख लेते हैं what you can do with alcohol. अगर आपके पास alcohol है तो उससे आप क्या करोगे, ठीक है? So if I have alcohol, I can burn it. So if I give it oxygen, it converts to carbon dioxide and water. That is one. Another reaction is I can convert it to ethoxide or whatever by adding sodium. Sodium is a strongly reactive metal, so sodium will react at room temperature. I don't even need to heat this thing. When this happens, it converts it to sodium ethoxide or methoxide or whatever ether you have, sodium ethers, or you can get sodium alkoxide, depending on how many alkyl groups you have. ठीक है? अगर आपने ये नहीं करना है, and you can do another thing. You can take an alcohol and you dehydrate it. Dehydration means you take a strong dehydrating agent like H2SO4.
Sir,
Yeah.
what does reacting with do? Does it make it into an ester?
I'm sorry?
Reacting with sodium make it into an ether?
Yeah, it's an ether because you don't have carbonyl. Ester के लिए आपको C double O चाहिए. यहाँ पे सिर्फ CO होता है.
ठीक है sir.
Yeah. If you strongly dehydrate them, there are two ways of dehydrating. One is you can use sulfuric acid at 200 degrees Celsius, or you can use Al2O3, but this time you need to give it high temperature. If you do that, you convert it to alkene. Okay. ये भी हमने देख लिया था. And this is dehydration. Then you have another way that you can convert it to halogen alkene. For that, you need to replace the OH group with the alcohol or with the halogen. अब उसके आपके पास तीन तरीके हैं. One is PCl5, one is PCl3, and one is SOCl2. Out of these, SOCl2 is the most clean because it does not produce any other byproduct in the same state. It produces HCl, it produces SO2. Both of them are gases. वो दोनों बाहर निकल जाती. और अगर आपने ये नहीं करना है, तो you have another method, which is you take HX acid but concentrated, like HCl or HI or HBr. तो वो भी basically the purpose of all four of these things is to provide the halogen. You just need to make sure that if you're using HCl or whatever, you can't have water because OH को वो आने नहीं देता भाई. Now you can also, जगह थोड़ी सी कम पड़ गई. Hold on. You can also convert alcohols to esters. So if you want to do that, then you will obviously need to do condensation reaction. For condensation, you need a carboxylic acid. And to facilitate this, you need a strong acid like concentrated sulfuric acid. This process is also done at 60 degrees Celsius and you heat it. So this converts it to ester by condensation process. And concentrated sulfuric acid is again acting as a dehydrating agent. Okay? And then you can convert alcohols to carbonyl by simple strong oxidation. वो strong oxidation आपके syllabus में potassium dichromate है, sodium dichromate है, potassium manganate है, ठीक है? And in this one, you just have to make sure that if you want to get aldehyde, you distill it. So अगर आपने carbonyl में से distill करना है, तो वो aldehyde देगा, ठीक है? और अगर आप distill नहीं करते हो, अगर आप इसको reflux करते हो, तो it will give you ketone for secondary and carboxylic acid for primary. But tertiary will not do it. Tertiary alcohols will not be oxidized no matter what you do. And lastly, there is one special reaction where you add iodine and sodium hydroxide solution, and that converts it to give yellow precipitate. If methyl and OH are on same carbon. So I think that is the summary of all the alcohol reactions. Take a moment to go through them and tell me if there is anything you don't understand. In सबके mechanisms, in सबकी names, requirements, सबकी आपको समझ होनी चाहिए कि कोई भी reaction क्यों होता है. Why do we need sulfuric acid? Why will PCl3 help? Why will SOCl2 help? Why do we need to add concentrated HCl or HBr or HI? या Al2O3 में टेम्परेचर ज्यादा क्यों है, सल्फ्यूरिक एसिड में कम क्यों है?
Sir, why is there less temperature in sulfuric acid and more in Al2O3?
Because concentrated sulfuric acid is what we call hygroscopic. Hygroscopic वो चीजें होती हैं which have a strong tendency to absorb water. So concentrated sulfuric acid बहुत जल्दी water absorb करता है. तो यहाँ पर कंडेंसेशन रिएक्शन हो रहा है, you want to remove water. तो sulfuric acid by itself उसमें आपको हेल्प कर रहा है, so you don't need to give external energy. हीट तो हम इसलिए कर रहे होते हैं कि रिएक्शन को एक्सटर्नल एनर्जी मिल रही हो ताकि वो जल्दी रिएक्ट करे. So एक वो खुद ही से कर रहा है तो we don't need to motivate it any further. But Al2O3 में we need to give it more heat.